Alright, so anybody that knows me or has watched the channel for very long knows that I love multimeters, I love test equipment. I believe you can't have too many multimeters. And today I've got a review of another Scopemeter by Gochifix. It's an oscilloscope, multimeter, and waveform generator. About a year ago we did a review of this 12 megahertz Scopemeter. Nice little entry-level multimeter and oscilloscope. It does have a waveform generator as well. And that did a really good job. I was pretty impressed with that. This one is a step up from that. This is an 80 megahertz oscilloscope and multimeter and waveform generator. They reached out and wanted to have us test and review this upgraded model. A little bit higher budget than the previous one, but if you're in the market for a decent Scopemeter dual channel, we'll go over all the specs, of course. Let's do a quick unboxing. I don't want to spend a lot of time just pulling the parts out of the box. I want to give you a good demonstration of its functions and features, pros and cons as I see them, and let's take a look. I have been testing this thing out for the last couple of weeks just to make sure that I'm familiar with it. The way I do reviews, I think it's unfair to you and a waste of your time if I just pull this thing out of the box and try to show you how it works when I don't have any idea how it works. So I've had it out of the box. I've ran it through the ringer, done a lot of tests with it, make sure I was familiar with it, and see how all the different functions work. So anyway, let's get into it and see what we get. So you do get one oscilloscope probe with it. Let's pull this out real quick. It does have two ports, but you just get the one. So if you want to add another channel, you'll have to get your own second probe. It uses a standard 1x 10x probe. It does have the calibrator on the plug. Little screwdriver that comes with it to adjust that calibrator. You've got some extra different colored rings if you want to colorize your probes. Taking a quick look. You got some sleeves that go over to the probe if you take the hook off. These are kind of handy if you're trying to pierce a probe, or if you're just trying to probe in a circuit board and you don't want to risk shorting something out. Comes with a little hook probe. So you got a hook here, you can hook stuff, but if you don't want to use the hook, you can just slide this off and then you have a pin. These other little sleeves allow you to slide over that. This particular one is for a piercing, a wire piercing. You can do that so it straddles the wire. Real quick, the manual that it comes with, there's 5 different possible probe combinations. It didn't have it marked when I received it. I checked with the manufacturer and they told me the one that comes with this is the P6060. It's a 60 megahertz probe, although this is an 80 megahertz scope, so I'm not sure if that will be a limiting factor or not. But it talks about doing your different compensations for the frequency, adjusting for your square wave and all that. Pretty nice manual that it comes with. Unlike a lot of the manuals you get with some of these equipment that are international, this entire manual is in English, and it's what, 50 pages. So 50 pages of content, all in English. From my reading through the manual, it is very thorough. It's got a lot of good information in there. And then you also do get a simple, kind of a quick start manual, which is very handy to just get you started. One single page for the oscilloscope operation, for the basics of that. And on the other side, you get a quick for the multimeter operation and the signal source, or the signal generator. And then there are instructions here for replacing the fuses. Unfortunately, they are not just plug and play fuses. They are soldered in. So if you really want to be cautious that you don't blow a fuse. So we'll cover some of the points on that to help you prevent that from happening. But yeah, they are soldered in fuses. I'll show you a little bit of information on those up on the screen here. Here's a close-up of those fuses on the inside. They are 6 millimeters long. The ones that comes with are soldered in. You would have to track those down. They're probably not too typical, and you're not going to go to the hardware store and pick those up. Those are going to have to be ordered if you damage those, so be cautious of that. We'll discuss some of the ways this helps to prevent that, some of the ways it doesn't. But we'll get into that in a bit. But nice little quick start operation guide. You get 2 standard multimeter probes. Pretty standard. Definitely seen worse. They're pretty flexible. Nice. Seem to be silicone wires. Comes with these little sleeves over the tips because They're fairly sharp, and you do get one BNC to alligator clip test lead. This is to attach to the signal generator output, and then you can get your different waveforms on that. And then the last comes with a USB-C, standard USB to USB-C charging plug. And then for the meter, you do get a nice little bag for it to give it some protection, keep it free from dust. So you can see here, this one is significantly bigger than the previous model that we tested. This is the 12 megahertz model, this is 80 megahertz. So quite a bit larger. So you got all your ports here across the bottom for the multimeter functions. Up on the top, you've got the signal generator out port, and then channel 1 and channel 2 for the oscilloscope probes on the top. And then on the side here you've got a USB-C charging plug. Now, I charged this up when I first took it out of the box a couple weeks ago, and I've done several hours worth of testing and learning how to operate the meter, and the batteries held up really nice. I'll show you some photographs here of the inside. I've taken this apart to take a look at the batteries, and the battery case. One nice thing is it does have a metal insert, so this is a machine screw with a brass sleeve in there, so pulling that in and out several times is not going to wear that out because it is metal, so that's nice to see. Now the screws for the whole case, those are just rough screws into plastic, so those you wouldn't want to pull in and out too often. You would have to take those out if you're going to change the fuses inside, so another reason you don't want to risk having to change those fuses frequently. But the batteries, then you don't need to pull the batteries out ever. It's got two 18650 2000 milliamp hour batteries in the case here, but of course they just charge from the USB, so you're not going to be pulling those in and out very frequently. Nice little kickstand for it. If you are going to take those covers off, you do need to peel off these side pieces. They just snap on. They're a little fiddly to get back on the ends because they fold under a little lip. Now, as far as the standard specifications, this is a 3-in-1 multifunctional meter that has the 80 megahertz analog oscilloscope. It has a 6,000 count digital multimeter, and then of course the signal generator. So in the waveform generator you have 3 different signal types. There's the sine wave, and on the sine wave you can go anywhere from a 1 hertz to a 5 megahertz signal. There's a triangle wave. Triangle wave gives you an option of 10 hertz up to 1 megahertz, and then the square wave you can do all the way from 10 hertz up to 1 megahertz. What it does, it shows you when you're on the various functions what output to use. Talk a little bit more about that in a bit, but so you can see right here, this is the output, that's the signal generator output, and it shows it on the screen which one to use for that. So you change the type with this button here, the F1 button, so right below the image you can change that, and it says ramp, that's your triangle wave, and then sine wave. If you want to change the frequency, you can press F2, and it's not touch screen, you just use the cursor keys here to select the frequency you want. Right now I have it on 6 hertz, so let's say I wanted to set it for 100 hertz, I would go 100, and then you can come over here and just hit OK if you want 100 hertz. If you want 100K, then you go up here and you select K. That would give you 100,000 hertz. M will give you megahertz. This one go up to 100 megahertz, so we won't set that, but let's set it to K, for example. And then your signal goes up to 100 kilohertz here, it shows. You can also change the voltage output between 0, 0.1, 0.2, 0.5, 1, 2, 3, and 5 volts peak to peak for your different outputs. When you're on square wave or triangle wave, it does have a 50% duty cycle. You cannot change that. It's fixed at that. At least not that I've been able to figure out. The button doesn't open that up to edit it at all, so it's just fixed. The oscilloscope, like I said, is 2-channel. You can read both channels simultaneously, and then you can also move those channels up and down when you're on the oscilloscope function, so you can separate them to view them each one independently and compare and contrast the two. It does also have a pretty substantial memory. When you're using the multimeter functions, it will record or let you save 2,000 sets of readings. If you're on the oscilloscope, you can save up to 200 waveforms in its memory, and then you can recall those back later if you want to review those. But a pretty nice memory that you can save values to. So, you know, for any reading you've got up there, if you just hit the save button here, it just saved that information. But then if I want to pull it back up, hit the menu button, and then I hit the OK button on this data, and then I can see those values that I've saved. So there's two different ones I just saved, and then of course you can erase those individually if you want to. According to specification, it'll give you about 10 hours of use after a full charge. Like I said, the battery indicators, it's either full or right at the top, and I've been playing around with this thing for a number of hours for the last couple of weeks after I did one full charge on it, so the batteries definitely last a long time. This one has a kind of a nice feature. It shows you what ports across the bottom to use for each different function. So for example, right now I have it on the voltmeter, and it's telling me I should use these two the common and the volt ohm capacitance test ports. And right down across here is where we select, here's our voltage that we're on now. If I want to check for impedance or capacitance or diode check, continuity, you just push that button. Same two ports for that. If I then go to the amperage, this is for the milliamp test, so I'm going to use the two center ports for that. That's these here, milliamps and common. And then if I switch to, instead of milliamps, I go to the regular amps. Now it's going to show me I'm going to use that far left port and the common. So now we're 10 amps and common. It's a very handy feature to make sure that you put your plugs for your probes into the correct ports. Because if you don't, you're going to blow those fuses. For example, if you are measuring current, so let's put it over here on the amperage. So let's say I was measuring amps over here on this setting. So here's our amps. So let's say I'm using those ports, and I got it here, but then I come back later and I want to check voltage, and I switch it to voltage. It's telling me to switch to those two ports over here, but if I forget, I am going to blow the fuse as soon as I put this on voltage, because that's going to be, depending on the current capacity of the thing I'm checking. Let's say I hook this up to my car battery, that's going to be able to put out hundreds of amps. I'm going to for sure blow this 10 amp fuse. So that's to help you remind you not to do that. Some meters, like my fluke meter that I have, and some others, they do actually have a buzzer linked to that, which I prefer. So if you switch to voltage, when you have them plugged into the wrong ports, it'll actually beep at you and say, hey, you're hooking this up wrong, you're going to damage it. That would be a nice feature to have, but without that, at least we've got the diagram up there to show you what to connect to, so that's a handy feature. The other one didn't have either of those. You just had to pay attention, make sure you didn't damage that. All right, let's run a couple of tests on the multimeter functions and show you those and see how that works. I've got a DC power supply up here, variable, that I can hook up to give us whatever DC voltage we want, up to about 30 volts. So I'm going to hook that up to here, making sure that I've got my probes into the right ports for my voltage measurement. So let's turn on my DC voltage source. I've got it set for 12 volts right now. Let's power that up and take a look. So it goes right to 12 volts. That's good. And symbols show that it's a DC volts. So the default range mode is auto ranging. That's if you don't know what voltage range the object you're trying to measure is. Now, if you don't need it to react that quickly, auto ranging is fine. It just takes it a little bit longer to acquire that voltage. If I'm looking for to see an inrush or a voltage drop on something, I might need it to react a little quicker. In that case, I would want to turn off the auto ranging. And how you do that is this auto button down here at the bottom. If I push auto one time, it'll just switch to the 60 volt range, so that means it'll read up to 60 volts. If I can hit it again, now it'll go up to 600 volts. So hit it again, it goes up to 1000 volts. Hit it again, goes back to goes to 600 millivolts. Hit it again, 6 volts, and then back to 60 volts, and it goes around. If I want to put it back in auto ranging, I can hold down that auto mode for a few seconds, and then I'll go back to auto mode, if you can see that there. So that's viewed up here. See where it says auto? In case you couldn't see that, I'll do it real quick here. So I hit it once, it goes to 60, 600. Oops, we skipped over 1000. Let me go back to it. There's 1000. And then 600. Goes back to 600, but also notice that it says millivolts over here, so that's a low range. And then 6 volts, and then 60. Let me demonstrate how much quicker it is if you don't have it in auto ranging mode. So let me put it back to auto range, and I'll turn off my voltage source. So right now it's on 600 millivolt range, and it would have to automatically reset itself. So when I first turn it on, so ready, set, go. So it took a couple of seconds to get acquired on that. If I turn off auto ranging, now if I turn it off and I turn it back on, ready, set, go. So you can see how much quicker it acquires that voltage. So if you're looking for a fast response, you definitely want to take it out of auto ranging and put it in a range that works for you. And then of course, it'll go, whatever range. And it's very accurate for my testing. Right on par with my, much more expensive fluke meters. Feature-wise, this is going to give you a lot more features than that other meter. So, and then, like I said, between each of these different modes, you then use these F1 through F4 keys to switch between the various test measurements within those other ranges. So, let me turn off my voltage here, and for example, if I'm on the volts, it says volts percent. And it's for or frequency, and this is AC or DC. So once I'm in that mode, I can do DC volts, AC volts. Let me real quick hook this up to an AC voltage supply, and we'll do a quick test on that. So I've got a step-up transformer here. It will give me up to 480 volts, and I'm supplying that a variable 0 to 120 volts through a variable transformer right here. So I can turn this up and down with varying my 120 volts to the step-up transformer. So my variac is all the way down. I got 2.8 volts. Let me slowly ramp that up. It is going to auto range, so we're going to see some swing in there. So I just switched ranges there. That's why you saw it blinked out real quick. Let me zoom in on that. So while you're swinging the voltage up, if you see it change, let me go back down so you can see that happen in real time. See right there, it blinked out for a second. That's when it switched from 600 volts down to 60 in the auto ranging. See how it switched up to the 600 volts? I'll keep turning it up. Right there's our 120 volts. And then of course I can go all the way up to 480. If you're curious, let's go ahead and power up the fluke just to compare readings. So yeah, we're about 2 to 3 volts difference between the two. Plus or minus a couple of volts is totally fine, especially when we're talking about 460. Let's go ahead and ramp this back down and see how close it is when we're down at the lower voltages. Yeah, so you can see at 120 volts, we're right at 120 here, 119.4, so half a volt off. And as long as we're measuring this, let's check the frequency. So this is line frequency in my house. So let's put this on hertz. If I put this on hertz here, we should see about 60 hertz. That's good. 60.01 hertz is the line frequency of our house. This is in the US. So I wanted to demonstrate another function that this has. It's not obvious. If you read through the manual, a lot of people don't really read the manuals. I read through it really thoroughly. There is a relative mode. It's on the trigger button. Let me demonstrate that for you. If I go to the resistance mode, what it allows you to do is to take the probes you're using out of the equation. So if I touch these together, now these probes are actually pretty nice. I'm not getting much differential there. But let's say I had, you know, an ohm of difference or something in my probes. I can make get rid of that value there so that I don't have to take, if I'm looking for a really precise resistance measurement, for example, and you can do this with voltage or anything, but any mode you're in on the multimeter, if you push this trigger button once, you see down here it says relative, and it says relative 0.000.1, so it's the difference between 0.1 ohms and whatever it is you're reading. So let me grab a resistor here. There's a big 20 ohm resistor. So if I put it across that, so there's 20.5. I mean, it's a low ohm resistance, but if I wasn't using that relative mode and I had some resistance in my wires, you know, that could throw that off by quite a percentage. So, and if I want to turn off relative mode, just hit that button again, and that'll put that 0.1 ohm back into it. But, you know, so anyway, relative mode is nice if you've got some resistance. You know, maybe your probe tips start getting dirty or oxidized, and there's some resistance there. You know, you can take that out of the equation. Also has so that's resistance mode. There's also a diode mode for checking diodes. Check this diode here. See what it says. So 0.472 that direction. Flip it around. Nothing. So that one's good. Touch them together. Now it doesn't beep in diode mode. A lot of meters will beep if you have it in diode mode and you got a dead short. You also have continuity mode. The screen actually says continuation. It means continuity mode. It's kind of weird. I don't know why they've called it that, but and it does appear to be latching. It's very responsive. So that's nice. And then you do have capacitance reading. If you go over here, all right, we got a couple of capacitors here. This one here is it's rated at 47 microfarads. Let's see what kind of number we get off of that. So let's put our reading across this cap. See what kind of number we get. And it's a little slower than the capacitance usually is. 77 microfarads. Huh. This is a pretty old capacitor, so it definitely wouldn't surprise me if it was out of that range. Just out of curiosity, let's check that with the fluke. Yeah, we're getting the similar reading with the fluke. So yeah, this capacitor is really old. You know, I've had it in my shelf for years. So 70 microfarads. That one's way out of spec. It's supposed to be 47. Yeah. So capacitance reading is always auto ranging. And of course, if you want to measure amperage, you can measure milliamps, milliamps DC, milliamps AC, or DC amps or AC amps. On these two, you're measuring up to 10 amps. On these two, you're in milliamps, and the maximum is 500 milliamps. And it's imperative that you don't exceed that, or you're going to damage those fuses. There are some optional menus you can select. If I hit the utility and I'm in the multimeter, you can turn on and off the key beeps. I had those turned off because they kind of get annoying after a while. But so the first one is beep. If I hit OK on that one, and I can turn that on. Now every time I hit a button, you can hear beep. So up to you if you want that. It might be handy if you're worried you might bump a button. Then it would tell you if you hit a different button. Anyway, so you can turn that beep on and off as desired. Let me turn that back off. You can also adjust the backlighting. So go backlight, and right now it's on 5. This is the brightest. Here's the lowest. I'll put it back on the brightest. So you can increase your battery capacity or battery life if you put that on a little bit lower setting. And then you can also adjust the auto power off. Right now it's set for 15 minutes. But you have 15 minutes, 30 minutes, 60 minutes, or never. If you don't ever want it to turn off, you could do that. Then it would just stay on until the battery dies. I'm going to go ahead and leave it on 15 minutes for now. So that's the utility menu. Over here, if you hit the other menu button, oh, that was utility. if I hit the menu button here, you pull up the data for anything you've saved with the save button. And also in this menu there's a calibrate. It does not, I don't have any instructions on how that works or how to use it, so I wouldn't recommend messing with that unless we can get a little information about how to use that, and if it's something that's for the operator to use or the end consumer. It might be something reserved for a factory reset or calibration. I fiddled with it a little bit and wasn't very intuitive, so I didn't know what was going on. It just tells you to unplug all the probes and go into it, but if you hit another button after that, it does some sort of self-test, but I don't know what it's testing for, so I would suggest you just don't mess with the calibrate. Go ahead and hook up an oscilloscope probe to this and do a couple of tests. I'll hook up port 1, or channel 1. Okay, so I've got my probe on channel 1. I'm going to put it on 10x. I had a conversation with the manufacturer about this because I wasn't clear. The manual states that this has got the oscilloscope section or function has a maximum voltage of 150 volts RMS if you're on the 1x setting, or 300 volts RMS if you're on 10x. And that equates to about 400, if I do my calculations, 424 volts peak to peak on 1x and 848 volts peak to peak on 10x. When I asked them, they informed me that the maximum on 1x was 80 volts peak to peak, which is quite a bit less than the manual that I had was showing, but they said 800 volts peak to peak on 10x. That seems to make more sense to me if we're talking 1 versus 10 times, but there's a discrepancy between the manual and what they're telling me, so I'm not 100% sure, but looks like 800 volts peak to peak is a pretty safe bet on 10x, so I would definitely try to keep it under that. And if you are checking any kind of mains voltages, I would do that on 10x. I wouldn't try to mess with that on 1x at all. One interesting test that I wanted to try, I've got some modified sine wave little power inverters, and I wanted to do a look at the waveform output of that. Modified sine wave, it's kind of a jagged, it's not a pure sine. Pure sine wave inverters for solar people, or the waveform should look like a pure sine wave, but I'm going to go ahead and hook this up to this modified sine wave, and let's take a look at what that waveform looks like on this meter. And this is a 120 volt coming out of this, so I need to be cautious. I've got some open-ended leads here. Alright, let's power up my inverter. Now I'm going to energize it. I'll zoom in on the oscilloscope here in a minute. Let's watch, make sure nothing goes up in smoke. Okay, got my AC on. Now, one thing you want to do generally, the best practice when you've got your when you've hooked up a signal of any kind, is to use the auto ranging, because that'll automatically find the best time base and voltage for whatever it is you're reading. Let me zoom in here for you. Okay, so I'm gonna hit auto. Now it says auto setting, so it's reading a little bit high. I'm gonna adjust this down. If I hit the down arrow, I'm changing my peak to peak voltage, or whatever, my voltage per division. So now I'm on 5 volts per division, and you can see that square wave. Let me zoom in a little bit more on that so you can see it. Okay, now I don't have a trigger set, so it's jumping around a little bit because I don't have a trigger set. So let's hit the trigger button here. Now with the trigger, you can set which channel does the trigger. Obviously I'm on channel 1. You can be rising or falling. Oops, let's turn that back on. You got a trigger mode. It's auto, single, or normal. Put it back in auto, and on the level you can reset it. Right now it's at 0, so there's no sense in resetting it, but while I have the trigger set, I can push the up arrow here, and I'm going to increase the trigger voltage. So once I get up above 0, so I don't know if you can see that, but I have a trigger voltage right now of 2 volts. So once it gets up to 2 volts, and you can see how it now stopped right where it was, and it's not moving around anymore. So up here in the upper left corner, 2 volts is my trigger voltage now, and as long as it's away from 0, it stops jumping around for the most part. So now I can get a good view of that waveform. And then if I hit, I go back and hit channel 1 to give me that menu back up, and now I can hit the left and right arrows to change the time base. Get a little better look at the waveform. If you hit the left arrow, it increases that time base, so I'm going to get more of that waveform in the screen. I hit the right, then I can spread it out. So now you can see the that modified sine wave. You know, it's not a pure sine wave, and that's why these modified sine wave inverters, I know some equipment doesn't really take kindly to those modified sine waves. So anyway, thought that'd be an interesting test to show you the modified sine wave pattern. And then when you do have the menu up for the particular channel, you can change it between DC coupling and AC coupling. So when you have it on DC, there's also ground, but if you have it on DC, it'll read AC or DC. If you put it on AC, it'll filter out the DC component. No, I didn't have that on the right probe. Look at that. So when you hit the channel, you also set the channel, the probe you want. It's on 1:1 right now, so let me switch that to 10:1. It also does have a 100:1 option on that probe if you had that kind of probe. So let me put it on 10:1. I'm going to do that test again because I had it on the wrong probe. So my probe is set for 10x, but I had it on 1x. Let me turn that back on. Let me hit auto again to there we go. So that first time it was a little weird because I had it on the wrong probe scaling. So when I hit auto, it maxed it out. It didn't really know how to dial it in properly. So that gives me a much better waveform now using the appropriate probe scaling and the matching scale on that channel. So there's my sine wave. Alright, so when I go to channel, let me set channel 1. You got your probe scaling. You also have a bandwidth limit. That just helps with some filtering if you've got some higher frequency noise going on. This one on the end here changes it to another menu. Let me turn it back on. Go to the end. And here you can change positioning. And then you can change the vertical and horizontal position. So if I want to do position, I hit F2. And then I could move that one up. You can see that green arrow now is moving up as I hit the up arrow. This is how you do it if you wanted to look at two waveforms simultaneously. You would want to move one of them up to the top half of the screen. As long as we're doing that, let's hook up a second channel. Alright, so I've hooked up a secondary probe that I already had to the same channel. I'm going to push channel 2 to turn on that channel because right now it's off. See, now both channels are on and you got both lines. But let me go ahead and activate channel 2, and I'm going to change the position because I want to lower that one down. And you can hold the button. Unlike some devices, you got to keep pushing the button. This one you can just hold the button down. Alright, so let me turn on the inverter again, and then we should be able to see these. I might have to adjust the scaling, so let me hit auto. There. Yeah, so I've got pretty much the same waveforms. Okay, I've got those scaled together. Now let's move the trigger up to get those to quit jumping around. So you can see I've got a really nice waveform on that. Now it looks like I need to calibrate that other probe a little bit. My edges are a little more round on that one, whereas the probe that came with the Gochifix is much more square. So while I've got that waveform there, if I hit the save button, it says save success. Now if I hit the menu button here, the top one is waveform. Those are my saved waveforms. Now if I hit the OK button on that one, I can scroll up and down with the arrows. But let me hit waveform. Now you can see there's my saved waveform, and it'll hold 200 different waveforms. So I can open that one back up if I want to see it again, or I can go to the next page and previous page. If I click on it, then I'm looking at the snapshot of that, and it shows me the volts peak to peak. It shows me the frequency. Okay, so if I want to exit that snapshot, I hit the enter button. Now I got my menu back, back, previous, next. So I hit enter, and now I got to hit back. And now it's my previews again. Hit back again. So now I'm out of that. Now I go back into the menu. This useful function, you can show additional data on the screen, so you don't have to actually do your own calculations with the oscilloscope. By reading the waveform. If I go to volts, I can click on that. Now over here I can show peak to peak. I can show volts peak, peak to peak, or volts max, volts minimum, average, or RMS. So let's look at peak to peak. We can turn that one on, and then let's also put on RMS. I can hit the left arrow to back out of that menu, or I can just hit the menu button again, and then that'll exit that. But now you can see I've got volts peak to peak of 300 and volts RMS of 122. But that's a handy feature because you can watch what your actual voltage is. You don't have to add up all the divisions to figure out what that is. So that is pretty much all I can think of to discuss on this. It's a very nice meter. Definitely a little higher budget for some of your average hobbyists, but if you want a dual channel scope that's pretty reasonably priced, as far as dual channel scopes go, this is a sub $200. And I do have a link. I don't have a affiliate link. I don't get any money for this. I'm not paid for this review. And I did get you guys a 20% discount if you if you enter Shane DIY, not Shane's DIY. They made it Shane DIY. So look carefully in the description. I've got it down there. If you want to pick one of these up, you can get a 20% discount using the link. You got to use the link in the description below. But again, that's not my affiliate link. It's just goes to the manufacturer's Amazon page, and if you use my discount code, you can get 20% off. So that's pretty substantial little discount off of this unit. But functionally, it works very well. Anyway, any questions, feel free to put them down in the description below. Happy to answer any questions, try any tests that anybody wants. I can hook it back up and run something just to see how it might do for your application. Hope this has been informative and interesting to you. Take care. Thanks a lot.